Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Off.
Hello, welcome to Astronomy Live. So it's 5:30 a.m. There were some passing clouds, but I think we're in a clearing right now. Of course, those clouds waited until my telescope was set up to show up. That's how it goes. But I think we're in the clear for the moment. So we're going to go try to find Comet Borisov. Alright, let me plug the coordinates of the comet into the telescope. The comet is near Regulus in the constellation Leo at the moment. Let's see here. Okay, make sure everything's running good there. Yep. Stream should be working well. Oh, I didn't mean to bring up email. Okay, let's see here. 2x2. Do a quick 1-second exposure. I don't see much. Do we have clouds? Yeah, we still do have some clouds in that area. They're moving off. Hopefully we'll be okay. We still do have some significant cloud cover in the east, waiting for that to move off before trying to really get going here. But I figured, well, telescope's already set up. I was starting to set up the camera and I noticed, hey, what the heck? Why are there clouds? It's been clear all night as far as I know. It was clear earlier this evening when I was streaming Saturn. It was clear when I started setting up the telescope. The moment I put the camera, the CCD, on the telescope, then I have problems. Then suddenly the clouds show up. That's how it goes sometimes, though. But I'd already gone through the process of polar aligning the telescope, not to mention setting it up, which is probably the biggest time sink in the whole setup process. So I figured I might as well just finish it and see if we can get some luck here between clouds. The comet is magnitude 16.8 according to Sky Safari Pro, so extremely dim. It will require clearing. If you have any cloud cover at all, we don't have a prayer of seeing it. Good morning. So you have some early risers joining us, or people from the UK there. Hi, Ewan. See, in the UK it's what, 10 a.m., 10:30 a.m.? Come on, the clouds are just lingering in the east. There's a few more little puffs coming out of the west. It's coming from the northwest down to the southeast. We have about an hour until astronomical twilight, so bear with me, and we will try to get this comet if we can, if there's any chance at all. Savings not on. Good. I can tell it's still real cloudy there, because even Regulus looks pretty dim, dimmer than it should. It's right at the edge of the clouds. We got another one moving in. It's just a train of clouds that are going right where I don't need them to go. Tell, at least, that we are pointed in the right location. I recognize that double star up there near the top on my sky chart. That is beautifully positioned. I might need to move things in the image. A little bit. To get the guide star that I want in view. But thank goodness for Sky Safari Pro. It lets me plan these observations. No, I'm not getting any kickbacks from them, but I just sincerely recommend that program for your phone or tablet. It's as powerful as any desktop planetarium software, basically. And it's so nice to be able to just look down at my phone or my tablet and see reticles of where the telescope's pointed, what the field of view is, and whether my guide star is going to be in the field of view. Okay, so like I say, I can tell we're pointed in the right location. The comet should be down here somewhere. So I'm going to move I'm going to try to move those double stars off to the right in the image. I don't know if they're really even showing up at this point. Oh, that's the wrong way. Start 2-second exposures instead. Pull it out a little more. It's moving up and to the right. See if we can move them down and to the right. Nope, wrong way, wrong way. Everything's reversed because of the mirror. I'm using the adaptive optics unit, which has a mirror on it, and it flips everything, all of my controls, where I need to be oriented with the camera. It's all flipped on me. But okay, I've got the directions going now. Okay, so now the critical question is whether or not... Yay, my guide star is in the field of view. Beautiful. So we have a nice bright guide star. Right there, right where I planned. And we're going to do 0.02. Boop, 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 boop. Okay, that's too dim. Or it just wasn't there. That's weird. Try again. Nope, nope, too dim. Okay. Fine. 0.06. It's still a little dimmer than I would like, especially with the clouds in the area. Okay, we'll go for 1/10 of a second. Okay, that's better. Okay, I'll turn on auto saving. Image with the main imaging chip. Do 1-minute exposures and go. Yeah, it's a sub-skill set of astronomy, cloud dodging. That's where I'm at tonight. I think we have a gap at the moment. Hard to say, but there are others coming shortly behind. And then a big gap. So there's a big gap coming after a series of small clouds that are going to be here in a minute or two. Hopefully I can sneak in an image in this little gap. We're going to try for 60-second exposures here, which is going to be real tricky at magnitude 16.8, but this comet is moving at a decent enough clip. I might be able to get away with 2-minute exposures, maybe. It's going to streak a little bit in 2 minutes. At 1 minute, I'm kind of thinking that is the limit of how long I can expose before the comet starts to move on to a new set of pixels. Negative 2,138 arc seconds per day. Man, I wish it gave that to me in arc seconds per minute, but alright, there's my first image. Okay, it's taking the dark frame now. Alright, let's see. Should be pretty close to the center of the image based on locations of the stars. Thinking it's going to be around here somewhere. There's a few galaxies scattered about the image, though. Those are going to be difficult to show up, I would imagine. Magnitude 17.5. That's even dimmer than the comet. 17.9. 17. 16.7. So 3 of the 4 galaxies that are in the field of view, according to Sky Safari, or there's a few more too, even smaller ones, but some of the largest ones, most of them are a little bit dimmer. One is about the same magnitude, a fraction of a magnitude brighter than the comet. Comet will hit about 45 degrees above the horizon at astronomical twilight. So I tried this back in September, I believe it was, and we didn't have any luck. And oh dear, the guide star is gone. I'm betting the clouds and blocking it now. And I don't want the telescope chasing its own tail, because it will. Yeah, I don't even see the guide star now in 1/10 of a second exposures. At 1.1 seconds now you can see that guide star is still there, but at the 1/10 of a second exposure it's not there because the cloud's blocking too much of the light. It's just faintly there. It's not good, so we're gonna have to wait. I'm gonna set this to 2 minutes. We're gonna try for 2-minute exposures at 2x2 binning. This down here is in about the right location to be the comet, actually. It's maybe a little too low. Yeah, no, that's a little too low. I think it's this other star. It's, okay, so the comet is about equidistant from this star here to these double stars along that same line. So right around here, maybe. And as before, when we did this in September, I'm going to try to stack the images using custom software that will pre-align them based on where the comet should be according to astrometry of the image. Okay, these clouds are passing, and I don't see anything behind me coming, so we should have a good few minutes here before we have any issues at this point. Still, that guide star is pretty dim. I think it is brightening. It's coming out of the clouds slowly. See if I can get back on it. Yeah, there we go. That's the way. Okay, so now we'll try a 2-minute exposure at 2x2 binning. So I'm binning the pixels 2x2, which eliminates the color data but increases the sensitivity at the expense of resolution. I am tempted to try 1x1 binning just to get the full resolution on it and see if there's anything. But the problem with that is that you're spreading the comet out over more pixels. By binning the pixels together, you enhance the sensitivity, which is definitely desirable with a very dim comet like this. You also buy yourself a little time from the comet's motion. As the comet moves, it will change from pixel to pixel where it's positioned in the image. And so you have to get above the noise level of those new pixels before it will start to show up. So by binning it 2x2, you decrease the angular resolution of the image, but this is actually a desirable thing when the comet is moving, because you buy yourself more time before the comet's motion brings it onto a new set of pixels where it has to start accumulating photons above the noise level of the chip. Now, I could use my active tracking software, theoretically, but the comet's motion isn't fast enough to make that worthwhile. The encoder resolution of the scope is fairly coarse compared to that, and so you wouldn't gain anything by doing that. You would gain sensitivity doing that if it were moving faster. If it were a near-Earth object traveling quickly across the field of view in the matter of minutes, then it makes sense to use my active NEO tracker software to keep the comet centered in the view. Because at that point the encoder's resolution doesn't matter anymore. It's good enough that it tracks the comet or asteroid well enough. Otherwise it jitters and it's not great. Okay, 2-minute exposure's in. We got this star here. We got something here. A couple stars here. So there's now more stars showing up in my view than on my sky chart. If I zoom in a little more, I get a few more stars on my sky chart here. Okay, what's that guy? I'm just trying to get an idea of the magnitude. That's magnitude 15. That guy there? Or is it? It's a little hard to say if it's that guy there or that guy there. Maybe down here. Oh, I think it's down here. Maybe this one's magnitude 15. Perhaps. So it's just taking a dark frame now. Hello, space for everyone. Trying to locate Comet Borisov this morning. Comet should be somewhere in this region. It might be right there. That might be it. I think there might be something faint there. These 2-minute exposures might be what we need, so I'm going to stick with that for now. Try to adjust the contrast a bit. Yeah. Hard to say. There might be something here, though. Good news is there's still no sign of clouds, knock on wood. And the comet's only going to get higher as we get closer to astronomical twilight. So the image quality will improve a little. You won't notice it necessarily, but when you go image to image, sometimes you can see it. Yeah, auto contrast is on, which might be helpful. It really maxes out the contrast, but it's hard to say if that's really in the right position or not. There's not supposed to be any stars at that position that I can see, but the sky chart that I'm using, Sky Safari Pro, it goes down to 16.6 there. And the Gaia stars, the Gaia catalog. Fortunately, they updated Sky Safari, with Sky Safari Pro 6, you can get the Gaia catalog on it, and that does help. In fact, let me increase the star magnitude here. Magnitude limit. Let's crank that up and really crank that up so I can really see what's going on here. Okay. Oh, that does help. But if anyone from the Sky Safari team is watching, feature request here. When I adjust the field rotation of the scope, or the rotation of the field of the scope, give me an option to lock the actual view of the program that way instead of having to try to crane my neck or rotate my phone. That would be most helpful. But yeah, the Gaia catalog is nice. So I can see all these stars now on the catalog and the sky chart. Let's see, that's these two, okay. Yeah. What magnitude are those? 15.1 and 16.3. Ooh boy, that's close. This faint one here is magnitude 16.3, which is awful close. That is really close to the magnitude of the comet. Granted, it's a point light source, and the important thing about the comet is it's a slightly extended light source because that magnitude is spread out over the area of the coma. And also, it's a predicted magnitude according to Sky Safari, so it may not be entirely accurate. The actual magnitude could be a little brighter or it could be a little dimmer than what Sky Safari is expecting. It's just sort of a ballpark. I take it as a ballpark figure. But that is encouraging to see that we have those stars in view. Okay, this guy down here is 16.8. Okay, yes. So this star right here is supposed to be the same magnitude as our comet. So we can confirm we've hit the desired limiting magnitude. The limiting magnitude of the image should provide enough sensitivity to detect the comet. That's exciting. The comet's a little brighter than it was back in September. I forget what day we did it on, but yeah, it was magnitude 18 on September 10th. Was it by the end of the month? 17.9. 17.7 versus now it's gained a magnitude at 16.8, which, as I say, is 16.8 is the same as this star right here. Should be in the image somewhere. Again, might have to stack these images to really pull it out, and stack them based on the predicted position of the comet using the comet's orbital elements. I've written a program to do that now. I still need to tweak it a bit for release, but it works well enough, I think, with these images, at least from my camera. Could your 5-inch telescope spot this comet? Probably not. This is an 8-inch LX200, and even this, even now, it's pushing the limits of what my telescope is capable of. It's right up to the limit of what my scope is capable of, even with the CCD. Because the comet is moving relatively fast, it's a hyperbolic comet, extremely hyperbolic comet, so even at a distance, the apparent motion of the comet is higher than what a normal long period comet would be. And so it's moving from pixel to pixel relatively quickly, in a minute or two. So you would have to actively track on the comet based on its orbit, and the limiting magnitude of a 5-inch scope is going to really hurt you, especially through the eyepiece. If you're just looking through the eyepiece, even with my telescope, it would not be possible to see this comet. It would be physically impossible. Your eye can't collect light the way a camera can over a period of a couple of minutes to generate an image. That's not how our eyes work. So that would be a non-starter, basically. So, sorry to say, this is a CCD only comet. Bring a camera or go home. And even with a camera, this is a challenge, a real challenge. To have a callback to my webcast earlier last night, or earlier this evening. Try doing this with your Nikon P1000. It won't work. Can you see this if you look through a toilet paper roll? Definitely not. Oof. D5300 is CMOS. Or was it 53? Yeah, 5300. I guess that's one of the Nikon SLRs. Well, you could do it with a CMOS, I suppose. If it's a high quality CMOS, yeah. Ooh, satellite streak. What are you? Is this thing set to my... Yeah, it's set to my current location. Oh, maybe I don't have satellites turned on. Show satellites. Yes. Mysterious. Mysterious. It's not on Sky Safari's catalog, at least. That doesn't mean a whole lot. Sky Safari's catalog is pretty far from complete when it comes to satellites. But it could be a classified satellite. It's possible. So, the comet could be right where my cursor is. It's about the right location. There does appear to be something there, maybe. It's really hard to say. If it is, it's just above the noise level of the camera, in the individual images at least. But that's okay, as long as we get above noise level, we can stack these images and make a nice, hopefully nicer image of the comet once we're done. Urban Astronomy says he has a 305mm Newtonian with a focal length of 1350 millimeters and a Mag 17 target is a challenge even with all conditions being great. Yeah, I would imagine so. So that's what? That's a 12-inch, basically? I do see clouds coming from the southwest. Pretty significant, actually. Pretty significant clouds. Come on, give me a few more images. We've got about 20 minutes from astronomical twilight now. Those clouds look like they mean business. It doesn't look like a thin band that will just go over and be done. So I think that's the curtain closing on this show, unfortunately. Bortle 8 skies. Ooh, very nice. I don't know what my Bortle level, my Bortle figure is, but I can see the Milky Way from here. It's decently dark. It's way better than where I used to live years ago. So, to me, it's a dream to be able to do this, not have to drive the telescope out somewhere away from the city lights, just be able to set it up, in my yard and do this. Is a nice change of pace. And yeah, it's just nice. So I still think, again, in this image there might be a cluster of pixels that are like a fuzziness that is just slightly above the background level. It's hard to say. I might be imagining things, but it's possible that that's the Interstellar Comet there, just faintly appearing. If we do get the comet, if I am able to stack these images and confirm that is the comet, it will have been the dimmest comet I've ever captured with this telescope, easily. And it's not going to be a pretty image or anything, but it's more for the sake of just having documented the comet, because it is interstellar. It's a extremely rare discovery. Clouds are starting to surround the constellation Orion. They're moving this way. I'll probably be lucky to get one more image after this one. Yeah, I think I saw it move. I bet that's the comet. Man, it's faint, but I bet it's there. I think we were able to get it this morning. That's fantastic, if that's the case. Hi, telescope guides. Hey, Carolina. Bortle 5 there in North Carolina. So, where I used to live was about Bortle 7, according to Clear Sky Clock. And I'm just curious, looking at the map, where I'm living now. Let's see. I don't know that I necessarily believe that's entirely accurate. It says I'm Bortle 5. Yeah, maybe. Maybe I'm Bortle 5. I still feel like I'm a little better than that. I'm probably 4.5, I would say. What telescope am I using? 8-inch LX200 Classic. Clouds haven't come towards Leo yet, so we're gonna keep going. Gonna keep going until we can't go anymore. So I think we have the comet here, right where my mouse cursor is pointed. I think that's it. There's just a faint smudge there, just above background light level, that is right where the comet should be, relative to the stars. As far as I can tell, that's about the right location. Not much to see, I know, but that's an interstellar visitor from outside of our solar system, which is just incredible. It's only the second interstellar object discovered, and they've both been discovered in the last couple of years. So I didn't get to see Oumuamua with my own telescope, so it's really nice to be able to get this one. Yeah. Goodbye, clear skies. Yeah, it's not the best morning for this. Usually the morning is better than early evening. This past evening was pretty clear, and then it decided that the clouds would show up in the early morning hours, so that's just how it goes sometimes. So, other equipment I'm using the S-Big ST2000 XCM as my CCD. It's actually the same CCD chip that is on the Mars Curiosity rover for the panoramic camera and some of the other cameras. The Maldi, I think, uses it as well. So to save on money and time, NASA basically bought these Kodak CCD chips off the shelf and used them on their rover. And they are single-shot color cameras, so the color images you see from Curiosity is true color, not using filters, but using color matrix on the CCD, the same as any other standard consumer camera, digital camera. Of course, this is a high-quality CCD, which also works well for deep sky imaging with the right electronics, which is what I've got here with the ST2000 XCM. In addition to that, I'm also using the SBIG A07. That's the adaptive optics unit, the original adaptive optics unit released by SBIG years ago. I picked one of these up for a steal, basically. It was practically being given away compared to the original retail price. I guess a lot of people didn't get much use out of them. They might have bought them, and they were a hefty investment at the time, but they do take a good bit of effort to set up, and you have to install it on the camera, and so it's a little bit of friction there in terms of using it. But I find it quite useful. I find it to be quite helpful because it is much faster at guiding on stars than the motors of an LX200. So normally with the SBIG, ST2000, or most other CCDs, you would use a guider that guides on a star and issues corrections to the motors of the telescope. But those motors are pretty slow, actually, at making those corrections, especially when there's slack in the gears. It can take them a few seconds even to take out the slack of the gears and catch up and make the correction. By that point, you've already streaked the image somewhat. So the A07 is a tilt-tip mirror that can instantly respond to the commands issued to it. So it's guiding at almost 10 hertz. I don't know, what are we at right now? Okay, 7.9, close to 8 hertz. So about 8 times a second, it's making corrections to the position of that guide star and keeping it centered, which prevents the image from streaking. You still have to polar align the telescope, otherwise you will get field rotation no matter what. So I had to polar align the telescope earlier tonight, which is what I did, but it's working well now with the A07. .260p McNaught. I don't think I got that one. That's interesting. Ben York. Yeah, it's an interesting point. Interstellar objects probably are more common than we think. I suspect as well. However, it's interesting that this one is not particularly dim. I mean, it is dim, but I mean, it's not particularly dim as far as the dimmest comets we tend to discover. It's pretty run-of-the-mill. You know, magnitude 16.8 is not unusual for comets you never hear about. There's comets discovered all the time that you never hear about. They're unremarkable for the most part. And sometimes the internet will latch onto one of them for various conspiracy theory reasons, like Comet Elenin was a perfect example. It was a pretty unremarkable, dim, fuzzy comet. Not much brighter than this one. And it had a name that people claimed was an anagram of, or not an anagram of abbreviate, or what do you call it? Can't think of 4 in the morning, but they said it stood for extinction level event Nibiru is near, right? It was claimed to be Nibiru or a sign of Nibiru, whatever. And it ended up disintegrating before it even made its closest approach to the sun, and it didn't survive the trip. And that's not unusual for small, dim comets. Now this one's dim partly because it's far away, and it's actually not going to approach the sun as closely as some of the long-period comets tend to in our solar system. But yeah, I think it is there. It's slowly moving to the right, I think, and that's where that's the direction it should be moving, according to Sky Safari. Based on the orientation of the camera, it's tilted. The camera itself is actually tilted at a funny angle. It's designed to do that with the A07, the adaptive optics unit, in order to make sure you can find a good, bright guide star. And at the angle it's tilted at, the comet should be moving to the right in the images, basically. So that does seem to be what's happening. So yeah, the curious thing, like I said, is that this comet is not like the dimmest comet we've ever found or anything like that. It's pretty run-of-the-mill for dim comets. And, large survey telescopes and even amateurs with telescopes much larger than mine are able to discover these things on a pretty regular basis. So it's kind of interesting that this is now the second such object discovered, and it does seem to be, I guess, pretty standard as comets go. The chemical composition, as far as I've heard, is pretty typical, and it would fit right in our solar system among other comets, except for the fact that it is extremely hyperbolic. So astronomical dawn has just hit in the last couple minutes. The images will start getting brighter from the background light as the sun gets closer to the horizon. And pretty quickly that will mean we'll have to end the show. That'll mean the comet will be hidden by the increasing twilight. But yeah, Ben York, I suspect you hit on an element of truth there, that these things are probably more common than we currently think. I'm sure there's more of these interstellar objects that pass through our solar system, but they're just too dim, too small for us to detect on a regular basis. But the strange thing, like I said, is this one is not particularly hard for us to detect as a species. So it's curious that in the whole history of modern astronomy, we haven't found one like this earlier. That said, astronomy is constantly getting better. Our telescopes are getting bigger, our CCDs are getting more sensitive, our technology is improving. It is probably true that 30 years ago, let's give it 30 years ago, discovering this comet would not have been a surefire bet. So yeah, maybe comets this bright that are interstellar pass through our solar system once, every few decades at least. And if that's the case, we may stand to find even more if we can find dimmer objects as well in the future. Yeah, go ahead, post the link, Urban Astronomy. I think link sharing is enabled. If the spam filter tries to catch it, I'll pass it through. Still got clouds in the southwest, but I guess they're not moving that direction. So, I gotta go take care of something real quick. I will be back in just a couple of minutes, guys. probably hear some of the cars going by. Some of my neighbors start to head off to work early this morning. I'm going to be wrapping up this webcast here in just a few minutes. But I do want to thank everyone for coming. Hope you all enjoyed the view. That's funny. Huh. I don't know why, it looks like YouTube has my old thumbnail for this video. I changed it to a comet picture. I thought, darn it, YouTube. Alright, well, I'll fix it later, but got a picture of Earth and the moon from Discoverer there instead. At least on my tablet. That's disappointing. Like I said, I changed it, but it didn't take. So, yeah, just to remind anyone who might be catching this in the last few minutes, the comet, the Interstellar Comet Borisov, I believe, is where the cursor's pointed. Is fuzzy, faint light here, about where the cursor's pointed. It's about the right location, and I think there's something there. It'll become clear with stacking whether that's really it or not. It could be hard to say. Some of the images, it comes out better than others. But now we're starting to get into astronomical twilight. The sky's going to be brightening, and that's going to make it impossible at some point here very shortly for the CCD to be able to detect it at all in the individual images. I'll be stacking these images and posting a stacked version. It'll still be grayscale. There's no color data due to the 2x2 binning here, but I will post a stacked image in the video description, as a link in the video description, hopefully later today. I might even be able to get to it this morning, assuming I can get it done pretty quick with the astrometry. So I'm going to be running astrometry on the images to align them based on the positions of the stars in the images, and then align them based on the orbital elements of the comet and the comet's predicted position from one image to the next, so that the comet stays in the same spot when you go to stack the images. So I'll stack the images. Hopefully that'll bring the comet out and enhance the signal to noise ratio to really be able to see it. And if successful, then I'll post the stacked image in the video description. I'm pretty sure that's it. It seems like it's been moving to the right in the images, which is the direction the comet should have been moving. So that's pretty exciting to me. It's not much to see, but it's exciting for what it represents, an interstellar visitor. Hopefully we continue to find more like this one, but regardless, it's pretty cool to see it traveling through the image here slowly. What do I do with my phone? It's up here. I think go I'll try to collect one more image after this, and then I've got to turn on the lights and start tearing things down. You guys have any last minute questions here in the chat? Let me know. It's interesting. I really haven't noticed much of an increase in the background light level yet. I was kind of waiting on that to give me my hint that it's time to go. Could be because of the auto contrast function, though. It's also probably because the comet is 45 degrees high at this point, so it's not as low on the horizon as it was back in September when I first tried this. Good evening. So, boy says, good evening from the Philippines, using a Nikon D750 and a Sigma 14 to 24 millimeter lens for astrophotography. What can you say about that camera? I'm not as familiar with the Nikons, to be honest. I've always used Canon. Back in the day when I was in college, many years ago, at this point, Nikons had sort of a bad reputation from what I heard from chatter online about them, that they had this function that would try to denoise the image and it would end up eating some of the dimmer stars. They would just get wiped out because they'd be mistaken for noise by the camera. I don't think that's true anymore, but that used to be the situation, and there was this goofy fix I heard for it where you would shut the camera off before it was done saving the image deliberately to try to prevent it from saving the denoised version. It was real goofy. I wouldn't advise doing that, but that's what I heard back in the day. So based on that, I went with Canon instead of Nikon. These days I think it's fine, and even in college I knew a good friend of mine who was really good at astrophotography. He used a Nikon. He swore by Nikon. So I think it's probably a great camera. The Sigma 14 to 24 millimeter lens sounds like a fantastic lens for. Yeah, definitely. That's got to be it. It's moving to the right. I swear it is. It's got to be. Yeah, it's got to be the comet there. So the Sigma lens sounds like it's great for wide field astrophotography, for really wide shots of the Milky Way and things like that. So you should have some good success with that. You just need a tripod and cable release and do some long exposures with it and see what you get. Have I ever done a moon bounce? Sort of, yeah. I participated in a moon bounce. I kind of helped align the antenna on the moon. It was a cloudy day in Alaska, and my brother and I were at a ham radio club where a guy was doing moon bouncing, and I'd always wanted to see that, so it was really cool. We did get some successful returns, and I guess they were doing an event that day. There were other hams in other parts of the country, and probably other parts of the world too, that were also bouncing, and you could pick up some of their signals. And so, like I said, it was a very cloudy day in Alaska. The moon was up, but you couldn't see it. So I think we used my phone, or I think maybe I had an iPod back then, I don't know, with a planetarium program. Probably was an early version of Sky Safari, actually, to see where the moon was in the sky and kind of line it up based on where the sensors predicted the moon should be. Because like I said, we couldn't see it, so we just aligned it based on planetarium software. Thanks for Saturn. Thanks, yeah. It wasn't my best work on Saturn, but it was easy, and it was just a targeted opportunity. I figured why not share it with you guys since I had the scope out, and I was just doing visual observing. But hey, I got my cell phone, got a cell phone holder, slap it on an eyepiece, and off you go. Any idea what you should get for lunch? I have no idea. It's noon there. Sandwich? Sub? The Mythbusters one. Oh, well that's visible light moon bouncing off the retro reflectors. Yeah, that's a whole another ball game there. No, I've never done that. That would be fantastic to do, but my understanding is you do need a larger scope than mine to really be able to do that, and a very powerful laser. Though I wonder if you really crank up the laser power, could you do it with a scope like mine? Maybe on the darkened side of the moon. I don't know. Probably not, but it'd be cool if you could. If you really crank that laser power up. To be able to get enough photons back that you could detect it with my scope, that would be amazing. Yeah, we're going to be hitting nautical dawn here in about 8 minutes, so I'm gonna have to wrap it up. People from my country could see this video, they will freak out. For some, comet is bad luck. Yeah, I heard about that earthquake yesterday. Sorry to hear about that. Yeah, you know, and the funny thing is there's comets this dim out there all the time. There's probably dozens of them, and any given time we know about a couple dozen of them that are out there around this, you know, magnitude, this dim. And it's just a normal background flux of comets coming and going. This one's unusual for being interstellar, though. That is highly unusual. A visitor from another solar system. Thanks. Alright, so we'll make this the last image of the night. It'll be a nice 24 images to stack. .48 images worth of light. That should be enough to pull this out, I think. High-priced Tex-Mex restaurants. Hey, don't knock the Tex-Mex. But yeah, they do tend to be on the higher price side of things, I guess. If you're not in the mood for that. Alright, that's gonna do it for this live webcast. Thank you all so much for watching. And like I said, I'll try to stack these images, and hopefully we'll have clear results confirming the comet. So thank you all for watching, and please subscribe for more, and I'll see you all next time. Clear skies, folks.